idea is to understand the idea is to understand the underlying concept of X machines. So I'm taking a course on front end masters, so I should be able to um, get my hands dirty in understanding what that whole concept is about, right? So just a simple JavaScript course. It's old, quite old. I believe, yeah. So I could look at, I could, yes. What I will do is const transition. First of all, maybe we reduce a bit. It's too much. What we'll do is npm install. Yeah, got transition and it's equals to, let's see. So we're making an assumption that states will look like this. Status, yeah. Let's see if that's a state, and the event will be fresh result reject, which makes sense for, yeah, which makes sense for this, right? Should I disable? I want to learn, so I will disable. I want to disable. Valid settings. I want actually. Let me sign out so I don't get Copilot suggestions. Yes, this is a learning session. Yep. I don't want auto suggestion. This is supposed to be a learning. Yeah, it's a learning session. I don't want Copilot suggestion. I just want to write the code by hand. That's better for me. So if we say, so if, for example, if we assume that a state, after doing the modeling, we do data modeling, we look at state and events, and like this, this is like an event-driven architecture. So I have a state that is idle, loading, and success, maybe, or just maybe idle and success. So I want to model that, and I can say based on the event, I will say switch. Thought I disabled that. Disable Copilot, yes please. Yes please. I want Copilot disabled. Yes, so we can say now we are looking at the states. So we are switching based on the states. Based on the state. We are using the state, based on the state, right? Based on this, we are switching with the state or something. We're saying yes, when the state is idle, what should they do? let's try to convert this to a TypeScript. If event.type is equal to, let's say, fetch. What should you do? Should just console the log. Started. So we are simulating fetching a promise, or resolving a promise rather. Fetching data. Starting. Yep. Starting to fetch data. One of the challenges we have in the AI era is that sometimes we no longer write code, which is so return. I want you to return status. Return status. Loading. So if it's idle. Yeah, that's what should be done. Right? For case, so which makes sense. Case loading. Break. Default. Break. Return state. Right. So I could say window. So I attach it to window and just do this because window is a big object in JavaScript on the web. Transition is supposed to transition. Yeah. At the same time, I could say right. I'm not using the XMachine library yet. We're just trying to understand what it means to model data. Okay. I'm looking at it, I'm saying that if that is the case, okay, console the log starting to fetch. So let's see what localhost 3000 looks like. Yep. Okay. What do we see is the state, status, if we say state dot is idle, this is the event type fetch. Okay, it's like the fetch. It returns object status loading. Makes sense. So we are trying to depict different states and different events that could possibly. Okay, we are trying to model our application in such a way that we are looking at different events corresponding to different states. Events are product of states and events are correlated in that an event can be triggered by either a user action or majorly by either a user action or the interaction of other part of our application. So when I'm looking at this, I'm saying that I have states, finite states, like we would look at later, finite state and events. So that when this idle is loading, so we have the when, given, when, then framework for thinking about states and events. Makes sense? Makes sense. So the idea is to understand, to have a mental framework of how these work, so I can apply it to the CLI I'm building. Yeah. Okay. Which makes sense, yes. I will use this for my CLI. Okay. So let's now look at machine, right? Yep.
An initial state. So remember, I'm just using this as a pure lookup table rather than something that we inject into a library, which we're going to be doing in the next lesson. So let's say I give it an initial state of idle. And so now I have a bunch of states. I have idle, and I have loading. So inside this object, I could specify that on the fetch event, we should, I'm just going to put this here, we should go to the loading state. We'll just keep it simple for now and keep it like this. By the way, the reason that I'm not just putting fetch directly on the object is because we might want to, or in the future, we're going to want to add entry and exit actions and other things. So this object doesn't just represent transitions, but it could represent other things as well. All right, so how do we use this machine to actually work?
Hold on.
Same way as this transition, to actually work.
No, let's go back a bit more. Let's look at.
All right.
Let's look at the machine first. Const machine. Good. Const machine. Initial. So idle. Yes, we have states in this case. We have several actions on the states. States idle. When it's idle, what should happen? What should happen is idle. Okay. On idle, we want to return fetch, which is just loading. Nice. Okay, so we have different stuff here. When it's idle, you can see loading now, loading states, right? That can be resolved to an empty object for now, which makes sense, right? Now we have machine. We can actually say window dot machine is equals to machine. machine. All right. So let's use.
So how do we use this machine, to actually work the same way as this transition machine over here? I'm going to call this transition 2, and let's give it a state and an event. So now instead of creating this big switch statement, we could just look it up on the object, and we could say const next states equals the machine dot states, and we're going to be grabbing the let's just grab the state over here, and remember we're putting it on state.status, the finite state, and then on, which might or might not exist, and the events.type. Now, if this doesn't give us a state, like if it's an event that we don't handle, then we're just going to return the current state. And then we could return status, next status.
Okay, cool. Now let's see. So let's use that as well. Const transition 2 will be equal to takes in the same thing, takes state and events like before, right? It's like the active part of the learning where I'm using arrow function instead of normal function. So we want to know what what the next status will be based on the state that is provided, right? Next status will now be equals to machine dot states if you look at the machine, machine dot states, the index of that machine dot state, the state that was provided dot status. If it's available, dot event type. Event type we are passing, that's the event type we are passing there. If it exists, fine, else return This makes sense. State dot status. Okay. Return status. Sense. In the same way, if I say transition 2, we do the same thing. We pass in status. This is idle, right? And we pass on an event type. Let's see, fetch. Yep, same thing. So with
just like that. So window.transition2 equals transition2, and let's test it out. So I'm also going to be, I'm going to be exporting or sharing the machine as well. So window.machine equals machine. And so if I console.log the machine, we're going to see that we have our machine over here, and then transition2. Now we could build up this initial state with status machine.initial, because we have it over here in a nice convenient property. And then we're going to send the events. Again, we're going to be sending a fetch event. And so what happens is it takes us to the loading state. So this is going to work exactly the same way as our switch statements. And it's going to default to staying at the same state if there are no transitions defined for that event. So whichever way you decide to write it without a library, whether you're using an object or a switch statement, it's up to you. The question was, is a transition function a reducer? And yes, the transition function is essentially a reducer. So if you're used to Redux or Vuex or NGRX or any
function is a reducer. Let me look that up a bit more. Let me go there. Mode for XState. What does it mean when we say that the transition is a reducer? Okay. Okay. So these are the current states. Takes in the old states. Makes sense. Make sense. Okay.
those other libraries that make use of these reducers, then it's pretty much the exact same thing. Some of the differences, though, are that while it does return the next state in response to a state in an event, it could also contain other things too, which we're going to be seeing in XState. And it sort of has this specific structure where this state is going to have some sort of field that represents the finite states of the machine. And of course, it could represent other things as well. But yeah, conceptually, you can think of it as a reducer. So again, going over the building blocks of what a finite state machine is. Now that we've seen it in code, let's take a look at it visually. So we have the idle state, and that was our initial state. So we also have a symbol that represents that this is an initial state. Now we also have loading. And so you can see these states are represented by boxes. So now if we want to describe
because we have to show another states. Makes sense. Okay, which is like where we began from. Okay, cool. So now this is where we start from. this is now loading state. Cool.
How the idle state moves to the loading states. In state machine notation, we would just draw an arrow like this, and then we would add the events that causes the transition. So, in this case, we have a fetch event. So now the graphical representation of this logic is exactly the same as we're expressing it in code, whether it's using the object or using the
fetch event.
the switch statements. And so to follow this, you would first look for the initial state. In this case, it's idle. And then depending on what events the machine receives, you would follow the arrow. So let's say we're in idle and the fetch event happened. So we're going to follow this arrow from idle to loading because that's where the fetch transition takes us. So now if we get a fetch transition or a fetch event in the loading states, then nothing's going to happen. And the reason nothing's going to happen is because there's no outgoing transitions from the loading states. And so this is exactly what a finite state machine really helps with, is preventing impossible states and transitions. If instead we had this arrow just floating randomly and going to the loading state, then there are the chance that we could have unintended transitions. But because this is a well-defined visual formalism, we know that it's impossible for our fetch events to do anything when we're in the loading states. Just looking at the graph, we could see nothing should happen.
What is the primary benefit of switching on state first rather than event type first machine? Interesting. Defensive logic and preventing possible transitions of states. Based on its current behavior. Set of behaviors, I presume. Yes, in state machine notation. Transition trigger by events. Transition trigger by events. Nothing happens because it stays in the current state because there's no event for it. How is a transition function conceptually related to Redux? It's essentially a reducer, which is what I Googled. It's able to spit. It takes in the previous state and some instruction and spits the current state.
We're going to be jumping into the first exercise. And so if you go to localhost port 3000/00 modeling, you could also access this by clicking the link over here. You're going to see a media player, and this doesn't exactly need to be hooked up just yet. It just serves as a visual guide for now. What we're going to be mainly doing is working in the console itself. And so for this exercise, what I want you to do is you're going to see a main.js file. We're going to be creating a simple state machine that represents the loading, play, and pause functionality of our media player. And so let's first create the state machine visually over here. So instead of loading, or sorry, instead of
understand the state machine, create the state machine, create the state machine, right? Yep, nice. If we're going to create a state machine, where is the GitHub? No. Zuzu modeling. Create a state machine. Let's see, 0.
the state machine visually over here. So instead of loading, or sorry, instead of idle, our initial state is going to be loading. And this represents loading the song. We're going to have a loaded event. And so according to the specification, when the song is loaded, we're going to start playing it. So the state machine goes to the playing state. Now, we could go back and forth between the playing and pause states using events. So we could go from playing to paused when we pause it. And we could go from pause to playing when the play event happens. So basically, I want you to represent this state machine in code without using any libraries. And yeah, so you could use either a switch statement or an object. And just like we did by attaching the transition function to the window.
Okay, so first of all, let's draw the states like we have it. Yep. This is the initial state. Initial state that we are in. Makes sense. This is an exercise that is good for us. Initial states. Given that it should be loading, from what we see, loading. Yep. That should be the first thing here. It's loaded. And it's loaded. Loaded. What am I doing? Loaded events should lead to playing. Okay, so playing event. Paused. It can be paused. These are the states. It can be in a paused And what event is that? What event is that? Yes. And that is when you post from there. We go back. To post it back to play, right? So we have this state here. Without using a library, right? Without using a library, so let's go back to, let me just move this to the right a bit. Without using a library, create a state machine. Okay, so what we are going to do, also make up a simple so what if I make it as a machine? Cast machine and machine is equals to so this machine will be equal to states, right? The states will be objects. Let's say loading. I'm trying to understand that, right? We're going to say loading. In that loading, we're going to have on the event we're going to have here is loaded. When it's loaded, what should it do? It should be play, right? I'm trying to understand what I'm doing, right? Yes. When it's loaded, it should be playing. Yes. I'm assuming when it is playing, I think so. If I look at what we did here, what did we say? Yes, loading. Yes, loading, fetch. Right. I'm assuming this. So we have playing, right? These are different states these are the possible states it can be in. So it could just be that when it's playing, we do the same thing on, and we call it, when it's playing, the only event that can happen to it is post, right? transition to playing. When it's playing, it's paused, pausing. I imagine. And when it is pausing or paused, when it is paused, that is the state that it is in. At that same time, what should it do? Yep. What should happen? I'm saying this is my assumption, right? Did I make any mistake there? Let's see. Yes. So custom machine. Could do that. So right. Transition. Transition will now be equal to state and events. Right. Now status will now be equals to machine dot status is after state dot status. lost it. Loading. Loaded. I have loading states. When it's loaded, it transitions to playing. When it's playing, it transitions to. When it's playing, the action I can take on it is paused. Transition to pausing. And when it's paused on playing, it transitions to playing. I think this is gonna make sense. Let's hope I did not miss anything.
Play around with it, look in the console, make sure that all of the transitions are actually working, and then if you want to, find a way to localize that state so you have this object that you could just send events to. If you don't get that far, then that's okay. We're going to be doing it together because that's going to be an important concept later on.
Nice. Okay.